Hi students, let's look at this question here, which was taken from the year 2015 VJC paper 2 question 11. I believe this question is on normal distribution. So a supermarket sells two different types of apples, Granny Smith and Fuji. The masses in grams of each type of apples are followed the normal distribution as below. So these are the distribution here. Two Fuji apples are chosen for a probability that their masses differs by at least 20 grams. So the thing now is essentially what we need to do is just define. So I'll just say that let G and F be the mass of a randomly chosen Granny Smith and Fuji apple, Granny Smith apples respectively. Yeah. Okay, so this is it. So once done, that's pretty okay. Just need to define first. So I would suggest we just put in grams, okay, because sometimes the questions will come out whether it's in kg or in whatever. So it's always good to just write down the mass in grams. So G, just this curly line here, 150, and that will be our standard 11.7 square, and F normal, and this is 180, 15.2 square. Okay, so there you go. So correct part 1, two Fuji apples are chosen for a probability that their masses differs by at least 20 grams. So this is the first part. The required probability is very important. You are looking at two Fuji apples, right? So if two Fuji apples are chosen, means two apples are involved, so it's F1 and F2. Alright, that is very important. Now find the probability that their masses differs by at least 20 grams. So differs just means modulus. Because it could be, why is it modulus? Because F1 minus F2, F1 can be heavier, F2 can be heavier, so it doesn't matter which one is it, but both can be heavier. Okay, differs just means, so if you merge these two up, it will just be F1 minus F2, differ by at least 20 grams. So this will be, sorry, this is 20, by at least 20. So this will be bigger than 20. This is the main thing here. Alright, so once this is at least, you can put an equal sign there, but because it's continuous, it doesn't really matter. So what we're going to do is actually just write this down. Required probability is P at least, so it's F1 minus F2 and at least 20 here. Okay, so this case here, if you were to do this properly, this is 1 minus P, F1 minus F2 less than 20. And we're just going to put minus P minus 20 to F1 minus F2, 20. Great. So this case here, once done, I'm going to just write this down as F1 minus F2. So we know that F1 minus F2, the mean will be 0 because the expectation is just, so this will be twice of 15.2 square. Alright, that's pretty okay. So once done, we're just going to key this in calculator. I think it's pretty okay. So we will have 0, and just root this for, I'm just keying calculator for you to see. Alright, here, so what we do is second distribution, normal CDF. Okay, and sorry, this is binomial CDF. So normal CDF, and the lower will be negative 20, and the upper limit will be 20. The mean will be 0. And this will just be square root of 2, 15.2, so 15.2 square. Alright, so this is it. Key in 1 minus this will be 0.3521. So this is 0.3521. Okay, this is 3SF. That's how we do this question here proficiently. Let's look at the second part. So second part, Granny Smith apples are sold at $3.50 per kg. And Fuji apples are sold at $5 per kg. So this is important. Granny Smith apples sold at, find the probability that Granny Smith apples and 4 Fuji apples cost more than $6.50. Now this is very, very important. 6 Granny Smith apple meaning G1 times 350. Okay, so you see that's why this 350 meaning is 1 this per gram, right? That is very important. So this will need to divide. This is in kg, so this need to change to gram. That's why it's very, very, very tricky. Okay, now the probability of you are taking 6 granite smiths, so it's G1 plus G2 plus G3 plus all the way to G6, right? And this will be multiplied with 350 over 1000 because this is in grams. Okay, the G1 to G6 are all in grams. The last one will be 5 over 1000. You just take F1 all the way to F4. Okay, so that is the cost. So find probability that 6 is more than 650. So the required probability for part 2, required probability is actually probability of maybe I just write this down. I think I just write this as the total cost. So C is equals to total cost. It's total cost. Okay, that will be 350 over 1000, and you have got 6 granite smiths, so G1 plus G2 all the way to G6. Okay, and you have got 4 Fuji apples, so it's 5 out of 1000, and this is F1 all the way to F4. Alright, so what you're going to do next is actually find the expectation, and the so expectation of C is pretty straightforward. It's just 3.5 over 1000 of E, of course it's 6 EG, right? Plus 5 over 1000 plus 4 EF, expectation of, which is EG, yeah, that is pretty okay. So the total cost, this case here, EG will be here, 150, this is 180. So just key in calculator, there will be, this is EG here is actually 150. Then expectation of a mass, so the mean is 180. So key in calculator, you get 3.5 over 1000 times 6 times 150 plus 5 over 1000 is 1000. Okay, times 4 times 180. That will be 6.75. So it's $6.75. You expect it to be about $6.75. Alright, that's okay. Then variance is the one which is sometimes students have a problem. This will be 3.50 because of this constant here. Just remember you need to square the constant. So this case it will be 3.51. The coefficient needs to be square. Variance G. Okay, G1. You basically do it 6 times, okay? So this case here, what we get is actually 3.5. Let me just write it down for you. Variance G6, okay? And this case will be 5, 1000. There's a lot of things to write. Square variance F1 all the way to 5 over 1000. Square variance F4. Then basically what we need is actually 6 times, because we have 6 times here. 6 times of variance G. And here is 4 times. Okay, so this case here, what we get is actually just 6 times 3.5 1000 square variance G plus 4 over 5 over 1000 square variance F. Okay, and now what we need is just key in variance F, variance G is given here, so this is actually 11.7 square. This is 12.2 square. Key in calculator. It's a lot of things to write there. You will eventually get 0.033165. Okay, so this is alright. Then you know that the total cost here, the distribution will follow a normal distribution, and we are looking at the required proper, hence C is normal distribution of 6.75, 0.033165, and required probability. You want to find that is more than 650. It's a PC more than 650. That will be key-in calculator. Second distribution. CDF. Then lower is 650. 10 to the power of 99. And 675. $6.75 and square root of 0.033165. 0.033165. Key-in calculator there, you'll get 0.91508. Okay, it's 0. A lot of things, right? 0.1915 91508 3SF. Okay, that's how we do this questionnaire proficiently. Okay, so for part 3, show set assumption needed for the calculation 1 to 3. Okay, this is very important. We need to assume that all apples are actually independent of each other, because if the apples are not independent of each other, it will affect each other, so it will not follow the normal distribution. It will then you need to consider, like the chain of events. But this case here, we just assume that each of it are independent of each other. That's very important. So just part 3, just make sure that we assume that the masses of all the apples are independent of each other. Okay, that's the important part. So any question or comments, please do let me know. Keep practicing and I'll see you in the next question.